This video is brought to you by mywayteaching.com.
So in this particular part, let us study about the acceleration due to gravity below and above the surface of the earth. You just consider this figure. Consider a point mass m at a height h. Okay, at a height h above the surface of the earth. You just consider a point mass m. The radius of the earth is denoted by re. Okay, since this point is outside the earth, its distance from the center of the earth, if you consider the distance from the center of the earth, then we can write it as distance from the center of the earth. We can write it as the radius of the earth plus height h, isn't it? Yes. If f of h denotes the magnitude of the force on this point mass m, then we can write this equation, that is f of h is the force on this point mass m, which is located at this point at the height h. So this force f of h, we can write it as g m e, mass of the earth and the mass of that small particle, and the distance is given by re plus h whole square. Okay, the acceleration experienced by the point mass is, we know acceleration experienced is f of h by m, which is the acceleration due to gravity, and we get the value of this as gme by re plus h whole square, isn't it? Let it be equation 2, let it be equation 1. So this is clearly less than the value of g on the surface of the earth, because the value of g is gme divided by re square. So here the denominator value is increased. See, re plus h means the value in the denominator is more. So obviously the result, whatever we get, will be less compared to this value. Here it contains only re. There is no h term in this particular equation. Let it be equation 3. Okay. For h less than re, we can expand the RHS of the equation 2. Okay, for if you consider the height which is less than the re, then we can expand the RHS of the equation. That is, equation means we can expand the RHS of this equation, that is g of h is equal to gme re plus h the whole square. This is equation number 2. So we can expand the RHS. If for h is less than re, g of h is equal to gme by re square 1 plus h by re the whole square, that is equal to, we know gme by re square is nothing but what? Yes, that is acceleration due to gravity on the surface of the earth. So g 1 plus h by re whole raised to minus 2. Okay, for h by re less than 1, we can use binomial expression. Then we'll get the value of g of h is equal to g into 1 minus 2h divided by re. So this equation 4, so we can call it as equation number 5. I can call it this one as equation number 4. So this equation number 5 tells us that for a small height h above the value of g, it decreases by a factor of 1 minus 2h by re. So here when we consider h, the h which is very much less than re, then the acceleration due to gravity above the surface of the earth is given by g into 1 plus he whole raised to minus 2. If we consider h by re less than 1, then using the binomial expression, we get acceleration due to gravity, that is g of h is equal to g 1 minus 2h by re, which tells that for a smaller heights h above the value of g decreases by the factor 1 minus 2h by re. So these expressions gives us the acceleration due to gravity above the surface of the earth. So now let us see acceleration due to gravity below the surface of the earth. So what will be the equation, okay, for that particular case? See, now you just consider the point mass m at a depth d here at this point. Okay, consider a point mass m at a depth d below the surface of the earth, so that its distance from the center of the earth is given by, in this particular case, the distance from the center of the earth is given by, see, the radius is re and this is d. So the distance from the center of the earth is what? This is re minus d. Yes. And a spherical shell of thickness d. The force on m due to the outer shell, the force on this mass m due to the outer shell of thickness d is 0, because the result quoted in the previous section, we already know that the force on the the spheres whose radius is greater than this re minus d will be 0. The force on this particular mass due to those outer layers will be 0. The all the force will be exerted by the inner sphere. As far as the smaller sphere of radius, that is re minus d, is concerned, the point mass is outside it, and hence, according to the result which is quoted earlier, the force due to this smaller sphere is just as if the entire mass of the sphere is concentrated at the center, isn't it? So, if ms is the mass of the smaller sphere that we have considered here, mass of this smaller sphere, then we can write ms by me, mass of this smaller sphere and the mass of the earth, is equal to re minus d whole cube divided by re cube. Okay, since mass of a sphere is proportional to the cube of its radius. So for a force on that point mass m, that force is given by the law of gravitation. F of t is equal to g ms m. Here we are considering mass of that sphere, not mass of the earth. You just remember that. And then the distance, that is re minus d, the whole square. Substituting for ms, we get, we know that ms by me is equal to what? Just now we studied, right? Re minus d whole cube divided by Re whole cube. So from this we can get the value of ms. So that is given by me Re minus d whole cube divided by Re cube. Substituting this value of ms in the equation of f of d, we'll get f of d is equal to g me m Re minus d by Re cube. Okay. So, and hence the acceleration due to gravity at a depth d is given by f of d by m. So, this is acceleration due to gravity at a depth d. So, that is given by g of d is equal to f of d by m. So, we can write g of d is equal to f of d by m gme by Re cube into Re minus d. So we know the acceleration due to gravity on the surface of the earth is gme by Re. So representing or replacing that value with the g, we get Re minus 1 minus d. We can write it as Re minus d by Re. In other words, we can write it as g 1 minus d by Re, isn't it? So thus, as we go down below the Earth's surface, the acceleration due to gravity decreases by the factor of 1 minus d by Re. Okay, acceleration due to gravity decreases by a factor of 1 minus d by Re. Okay, as we go deeper. So, the remarkable thing about acceleration due to gravity is that it is maximum on its surface and decreasing when you go up or down. So, this is a very interesting thing. So, acceleration due to gravity is maximum at the surface of the earth. Only at the surface of the earth So as we go up above the surface of the earth, or as we go down below the surface of the earth, its value will decrease. Okay, acceleration due to gravity will decrease in both the cases.